Okay, so today we're kind of using like the things that we've learned the past week or so and applying it to find different answers. All right, first of all, I forgot equals and f of x but when I printed that out. So if you want to stick that in there in the front or the end, it's not an equation. It's not a function because it was missing that. This says to find the remaining zeros using the given zero or given zeros and rewrite the equation in factored form. So we're doing two things. We're finding all the zeros and we're rewriting the equation in factored form. You can use a graphing calculator to verify your results, but we're not going to go through that today. So we're just pretty much finding zeros and rewriting. So if you were going to look at this function and I say factor it, what would be your first step for factoring? Huh? Maybe? But like if you do grouping, you'd have to factor something out so that the groups match. If I do grouping here, like, no, can't do that for factoring. It's got to say equals 0. Or equals, like, this would be 0. If we're finding the zeros, then this would be 0. I didn't mean to write that in yellow. So if we're finding the zeros, then that means make that equal to 0. So it should say equal 0. So the thing is, we can't really factor this. You have, hopefully, in Algebra 2, learned what to do to factor it, which we will review in about 2 sections. We're just doing baby steps to get there. So today, we are given 2 of the factors, and we have to factor it all the way. Okay, so we're baby stepping our way to do it from scratch. Since I'm given 2 of the factors, I can divide out both of those factors and see what I have left. How do we divide out or? So what could I use for dividing out x minus 2? I can use synthetic. So if I can, I'm going to use synthetic. So we're going to take this equation or function and take out the x minus 2 by putting what number here? 2. And we bring down our coefficients, check for placeholders, and perform synthetic division. Okay, so once we perform synthetic division, we should get a 0 here because I was told this is a factor. That means there shouldn't be a remainder. So when you're doing this, if you are using a factor and you get a remainder, you're doing it wrong. Okay, because they're telling me this is a factor. So it should be 0. Now, since this is a remainder and there isn't one, I don't really need this at all. What I have is I have a function left that I'm now going to divide out x plus 3 from this function. So I'm going to perform synthetic division a second time on what's left over. So I'm going to do negative 3 as my value outside that I'm dividing. And I should get another remainder of 0 because it's telling me these are factors, they should go evenly. So once I factor that out, what polynomial is left?
X squared plus 5x. What's
2x squared plus 5x plus 3. That's the polynomial that I have left. And at this point, can I factor 3 terms?
Yeah.
Hopefully. How?
2. Right.
Guess and check. 2x, x. They're both positive, so I know these have to be positive. One has to be 3, one has to be 1. Figure out where they go. So my goal is to write this in factored form and to find all the zeros. So while I just did this, can we just figure out the zeros real fast? While it's here right in front of me. How do I figure out the zeros? Set each one equal to 0. Now I want you to pay special attention, just going off on a side note because I know it's in the homework. Notice that when I had a fraction 0, my factor does not have a fraction in it. When I have a fraction 0, my factor doesn't have a fraction in it. Okay, that's important when you go to do your homework and you have time to start it in class and you get to that step. You'll see. Hopefully. Okay, so let's write our factored form. F of x equals 2x plus 3, x plus 1. What other factors does this have?
X minus 6.
Right, they gave it to us, right? X minus 2 and x plus 3. So I have 4 x's. I have x to the 4th if I were to multiply it all together. Does that kind of match my original question? 2x to the 4th is the first term. Okay. So that's factored form. And then the zeros, we're going to say x equals, and there's going to be 4 of them, so we're going to do fancy brackets, and we list them in order. So what's the smallest 0? Or most negative? Negative 3, then negative 3/2, then negative 1, and then 2. All right? Example 5 is a similar question. This time, I'm not giving you a factor. I'm instead giving you a 0. We're going to do kind of the same stuff. We're going to factor out that 0 to find anything else that we can. So we're going to do negative 1, and 1, 6, 11, 6, 0. Remember, if it's missing one of the powers of x, you have to put in a placeholder.
So X.
There's x to the 0 at the end. Remember, it always ends in a constant.
Yeah.
It's like x to the 0. I gave you this one so you know what to do if it was missing the last term. Okay. So then we perform our synthetic division. And our remainder has to be, if I've done it correctly, 0, which it is. So that's a remainder. I don't need that. But that other 0 I do need, kind of. I don't know any other factors, so I'm going to go ahead and write this polynomial. What's going to be my power for my first x? So how am I going to factor that?
You can take an X out.
GCS?
X. So
I'm trying to do the next step by accident. X what?
X plus.
Sometimes those 5s and 6s mess with our heads. So we have factored form. F of x equals x times x plus 3 times x plus 2. And what's the third one? X plus 1, right? So we're kind of using all these things that we've already learned to do something kind of different. Okay? And then the zeros. X equals, fancy bracket, what's the first one? Negative 3, negative 2, negative 1, 0. Tangents to be fun. You always are. Not you. You all always are good. Okay, last one. I left you a little space to write yourself a note. There's something special when one of our factors has a radical in it. So if factor has radical, but function only has integer coefficients, that's what we have right here. We have a radical as one of our factors, and then you look at the function and there's only integers. There's no radicals over there. There will be a conjugate 0 for factor. There will be a conjugate. You remember the term conjugate? So one of them's x equals 2 plus radical 5. The other one's x equals 2 minus radical 5. Conjugate. How many total factors, how many total zeros should I have according to this function? I should have 3. There's 2 of them. So we got to find the third one. All right? So you're going to follow these steps. If there are 2 of them, they're radicals. We need to find another one. What we're going to have to do is we're going to have to multiply these together. We have to multiply them together as factors. Right now they're not written as factors. So to make them into factors, you have to make this say equals 0. So we're going to move the 2 over and move the radical 5 over. X minus 2 minus radical 5. Over here, x minus 2 plus radical 5. So we can write them as factors. Which for our final answer, we need to write all the factors. We already figured out 2 of them. But to figure out the third one, we have to multiply these together. Okay? Let's review how to multiply 3 terms times 3 terms. X distribute to all 3 terms. I'm going to write my answer, or for the x, I'm going to write x squared minus 2x plus x radical 5. Next thing I have to do is I have to distribute the minus 2 to all 3 terms. And when I write that in my work, I organize it this way every single time because it helps combine like terms in the end. I always move over one column and I go underneath it. So when I do negative 2 times x, that goes right under that one. I do negative 2 times negative 2 plus 4. Then negative 2 times radical 5, negative 2 radical 5. Okay, and then I'm going to distribute the minus radical 5 to all 3 of those. And I'm going to drop down a line and go over a column. So I get minus x radical 5. And I get plus 2 radical 5. And then my last one is negative times positive, so minus. And radical 5 times radical 5 is 5. So if you multiply by the conjugate correctly, all of the radicals will cancel each other out. You won't have any radicals in your answer. Okay, so that is the 2 of those factors multiplied together. How do we find what to multiply that one by to get the original question? You have to use division. You have to divide this guy into the original. So how am I going to use division when I've got an x squared? It has to be long division. So we practiced what we went over yesterday. We're going to take x squared and go into x cubed. How many times?
X squared, you do X, you multiply X squared by X, is X, and a third, right?
Yeah. I said one.
No, just multiply X squared by X.
X is the answer. I just did. Okay, so x, and then we distribute x to all three of those terms. I'm going to get x to the third minus 4x squared minus 1x. Then what do? Draw the line, change the signs. And we add. We get negative 3x squared plus 12x. And we bring down the 3. And we divide again. X squared goes into negative 3x squared. How many times? Negative 3 times. And then we distribute negative 3. Negative 3x squared, positive 12x, positive 3. We draw the line, change the signs. And if you've done this right, it should give you a remainder of 0. These are all checks, like, okay, I'm not getting a remainder of 0, there's something wrong. If you've done it right, it should give you a remainder of 0 because these should all be factors. So let's write it in factored form. F of x. Nope, this one is not f of x, is it? This one has the factors and it has x equals 0 at the end, right? Is that correct on this one? Yeah. So this one, we'll just keep it in the same form they gave it to us in. So we'll have, our first factor is x minus 3. It doesn't really matter the order. Another factor is x minus 2 minus radical 5. And then x minus 2 plus radical 5 equals 0. So just keep it in the form that they give it to you in. If they say equals 0, leave it as equals 0. The only thing you changed was factor. And then the zeros, x equals fancy bracket 3 and 2 plus or minus square root 5. All right? I'm not going to do it. I'm just going to pass out. The homework is over the sheet. When you get your homework, we just got to talk about some directions on the back. So everybody knows what to do on the back when you get your homework. The rest class work on it. Stick together. So when you get your homework, look at the back real fast. Numbers 8 and 9 are not what we did today. They were what we did in like section 2-1. So I just wanted to start reviewing for our quiz for Friday since this is a pretty short assignment. This says to sketch a graph and fill out all the information. You don't have to go in this order without the use of a graphing calculator. So all of this should be no calculator. I'm not going to go home and make sure that you're not using a calculator, but this is what it's going to be like on the quiz. So you should be practicing that way. And then if you get stuck and you don't know how not to use your graphing calculator, ask me questions. Okay? And then right here where it says end behavior using symbols, that's where I'm talking about doing that f of x approaches some sort of infinity as x approaches some sort of infinity. Like write it that way so that we practice it before Friday. We'll make sure we saw it again before Friday, okay? All right, so go ahead and get started. Ask me questions if you have any, when you have them.